Discuss the different ways of representing a set. So to begin with, let us choose a simple set A which has elements 1, 2, 3, 4 and 5. So what are the different ways we can represent this set? So let me first tell you that this set is already been represented in a certain way. So this form or this method of representing a set is known as the roster form or also the tabular form. So set A with elements 1, 2, 3, 4, 5 is already in roster form or the tabular form. We can convert this set into another form, which is known as the set builder form. Writing it for you, set builder form. So basically here we are trying to convert roster form or the tabular form into set builder form. So set A, our set A has elements 1, 2, 3, 4 and 5. So let us see how do we write this. Curly brackets as a rule. So X is such that, now what is the nature of the elements? So these elements are 1, 2, 3, 4, 5. So greater than or equal to 1 but less than or equal to 5. So you can write it as X is such that X is greater than or equal to 1 but less than or equal to 5, and X belongs to, what kind of numbers are these? These are all natural numbers. So this is the way we write a set builder form. Set builder form, sometimes it is also known as the property form, but popular name is the set builder form. 1, 2, 3, 4, 5 can be represented as, if you find this form difficult, so you can also write it as, to begin with, say for beginners, you could write it as X is such that X is such that X is a natural number and X is less than or equal to 5. Natural number less than or equal to 5. So we know that natural numbers begin with 1. So 1, 2, 3, 4 and 5. So this is the desired set. So if you find this method difficult, you can obviously write it like this, and gradually when you become more confident, you can gradually move towards the actual way of writing in set builder form. So let us discuss one more example. I'll scroll down. Yeah, so say for example now you have a set which has got elements, so let this set be B, and now you have elements 2, 4, 6 and 8. So again this is already in roster form, and we will try to convert it into a set builder form. Set B. Again we will try to decode the nature of these elements. What kind of elements are these? These are 2, 4, 6 and 8. So can I write 2 as 2 into 1, 4 as 2 into 2, 6 as 2 into 3 and 8 as 2 into 4. So I could decode a pattern here, and the pattern here is 2n, 2 into 2 multiplied by n. So what do I write here? I'll write X is such that X is equal to 2n. So each element is equal to 2n, where n is less than or equal to 4. N is less than or equal to 4. So n can be 1, 2, 3, 4. Can it be 0? No, it cannot be 0, because we'll specify that n belongs to natural numbers, so we cannot take 0. So this is how we have converted this roster form into the set builder form. So now we have discussed two forms of representing a set. One is the roster form, the other one is the set builder form. We should know how to convert roster into set builder and set builder to roster. There is one more way of representing a set. Say for example, let us take the same set B. This one is very simple. This is generally known as, popularly known as the visual form. Visual form or the visual method of representing a set. So we make a loop, name it B because our set name is B, and then we will write the elements 2, 4, 6 and 8. That is it. So this is the easiest one. In the previous example, our elements were, the set A had elements 1, 2, 3, 4 and 5. So if you have to represent set A in visual form, you will simply make a loop, write A because this is set A, and the elements 1, 2, 3, 4 and 5. So what we have discussed, that there are basically three ways of representing a set, and these are: the first one, the roster form. So this is in roster form. The second one is the set builder form. I'll scroll up for you. This is an example of set builder form. And the third one, the easiest one, is the visual form. Okay, the visual method. So these are the three ways or methods through which we can represent a set. So I think now you know what is a set. How do we define a set? A set should have elements which are distinct, and set should have elements which are well defined. So I hope there is no confusion in these two important words, well defined and distinct. I'll take you back to the definition that we wrote. Just a second. Here it is. So a set is a well-defined collection of distinct objects. So objects should be distinct, there should not be any repetition, and well-defined. So there should not be any ambiguity in the statements. I'll just discuss the example. This example 3. All beautiful people in Texas. So this statement is not very well defined because our perception for beauty is different. Suppose I say all good players of basketball. So again, good player of basketball is not clearly defined, or all good students, or all good citizens of US. So how do I select good citizens? What is my criteria to select good citizens? It is extremely important. Are the taxpayers good citizens, or the law-obeying people are good citizens? So all of us may have different perceptions for defining good citizens. So these statements are not very well defined. So we know what a set is, and now we also know the language required to represent a set, and then we know what are the different ways through which we can represent a set: the roster form, the set builder form, and the visual form, making a simple loop. Now let us discuss some examples, and I'll share some examples with you which you can practice. So let us begin some practice questions. So try to convert these sets. So convert these sets, I mean, if it is in set builder form, try to convert into roster. If it is in roster, try to convert into set builder form. So I write, say example 1, the set of all letters, in the word mathematics. So recall the definition of a set. Elements have to be distinct, they have to be well defined. And here This is in set builder form, the set of all letters in the word mathematics. So you have to convert this into roster form. So this will be your first task. Okay, so let me solve the first one, say, for you. So I'll begin by making a bracket. M, obviously M, A, T, H. Just focus on the letters. E. Can I use M again? If I use M again, I already have used M1. So I go against the definition of set, which says distinct elements. I cannot repeat elements. So I cannot use M here. So I cannot use A. I cannot use M. I cannot use A because I have used A. Can I use T? No, I have already used T. Can I use I? Yes. I can be used. C, yes, and S. So the roster form for the first question is MATHEICS. So this is your answer. The second question, try solving the second one. Second is the set of all letters in the word, which word should I give you? Okay, let it be algebra. Algebra. Okay, so this will be a task for you. Question number 2, you will have to solve. I'll just give you a few more. See, 3, question number 3, the set of all vowels in the word equation. Okay, so be careful here. I'm not talking about letters here, I'm talking about vowels. Okay, so be careful, emphasize. Okay, so this is again your task, your assignment. 2 and 3. Question number 4. Okay, so the set of squares of integers, set of squares of integers. This is for you, again a task. I will give you a hint here. Your hint is, while making the set, please keep in mind that -2 square is 4 and +2 square is also 4. So the set, this set should consist of squares of integers, So please remember this hint. Okay. Question number 5. Okay. So I'll frame it in set builder form for you. X is such that X is a positive integer and is a divisor of 18. So we are talking about positive integers here. So you have got limited options, 1, 2, 3, 4, and so on. Then you have to select which one of them are actually divisors of 18. So that will be your answer. So this is again a hint for you. Okay. Question number 6. So don't look for negative integers. Just focus on the positive ones. Yeah. Question number 6. I'll write in set builder form. We will convert it into roster. X is such that X is an integer. So integer and x plus 1 is equal to 1. Okay. So x is an integer and x plus 1 is equal to 1. So okay, let me give you a hint again here. So x plus 1, focus here, the important thing is x plus 1 is equal to 1. So say x is equal to 1. So if we put 1 here, so we get 1 plus 1 2, so this becomes greater than 1. So by logic we can understand that this x has to be less than 1. So what choice do I have? This x has to be less than 1, and we cannot take fractions because we are talking about integers here. So I have to choose 0. So if I choose 0 instead of x, so 0 plus 1 equal to 1. Do I get 1? Yes, I do get 1. So this. Okay, so this is your answer. Okay, sixth one. Okay, question number 7. Question number 7. X is such that x is an integer. X is an integer and x square is equal to 9. So again I'm talking about integers, so you know that plus 3 square is 9 and minus 3 square is also equal to 9. So this is another hint. So keep this in mind before you convert or try to convert this into the roster form. Okay, so this will be, these questions will be your assignment.